I go places, talk to people, mostly about architecture, cloud-related topics. First time someone called me that, I thought, yeah, that's actually a pretty fitting definition of what I do, although I did sound the acronym out in my head and realized they may not have intended it as a compliment, but I try to take it in the most positive light that I can. Well, thank you all for joining me here bright and early on I want to say Wednesday morning. I'm not entirely sure. My body reacts very strangely to jet lag even after all these years. The first night's very easy because you're very tired from the red-eye flight, and so you just collapse like a ton of bricks. And then the next night your body says, no, I'm not quite ready to be in this time zone, so we're not going to go to bed until 2, 3 in the morning because that's more like what it would be back home. So I've written a lot about architecture, so if you're interested in my thoughts on that topic, you can grab this little prose report thing that I wrote a few years back based on a lot of my thoughts around what does it mean to be an architect, how do we do this job, how do we deal with trade-offs and all that fun stuff that we have in this architecture space that I've lived in now longer than I care to admit. And a little more germane to what we'll talk about here today is microservices. Right, so I put this piece together talking about some of the principles we use when we're talking with clients about when should something be a microservice. We have this tendency in this industry to get really locked in on a tool and decide that's the answer to every single problem. I must use it everywhere. That's rarely the right choice. And so this will at least give you a few of my thoughts around when it makes sense to use microservices and maybe when it doesn't. All right, so I've been in this cloud space for quite a while here, and it's very clear there's a lot of options. There's a lot of different things we can use. There's a lot of things in the toolkit. You know, we could obviously use microservices. We could do modular monoliths. We could throw everything in containers. And let's not forget about that functions thing. You know, you can pretty much put anything in front of as a service, and it's probably a thing. We have to realize that polycloud is likely part of our world, or hybrid, or some similar combination of things. Now, our job used to be simpler. I wouldn't say easy. It's never been easy. You know, by the time we kind of figure out what we're doing, we come up with new abstractions and our customers ask us to do more and more complicated things. And that's basically been software since the first computer was invented, rinse, repeat. But back in the day, we had a monolith or two and we released periodically for some value of periodically. We all worked near each other, maybe not on the same floor, but we could at least walk to each other's cubes. That's not the world we live in today. There's a pretty good chance that you don't have 1 or 2 monoliths. You have dozens or hundreds or thousands, or we're not actually sure how many services we have because new ones are being deployed and old ones are being decommissioned. And well, we deployed multiple times today, so I'm not even sure exactly which version we're talking to. And we don't all live in the same time zone. You know, my team is distributed all across the globe. You know, in fact, I think there's only maybe 3 people that are in the same time zone on my team. Now, being an architect was never easy, but now I have to deal with these massively distributed applications, which have all sorts of new fun edge cases, and I'm building them with teams that are spread around the world. So what do I do about that? Now, I'd like to tell you that there's a magic wand that I can sell you, and you can just make this all work. You know, some people do believe there are magic sparkle ponies. There's not. That would be really cool. So how do we avoid the pitfalls of this? And how do we make sure that we aren't practicing resume-driven design? I've seen this a lot in my career. You know, as an architect, one of the things I've had to deal with considerably is a developer will come to me and say, we have to use X on this project. And I'll say, well, that's great, why? And they'll just repeat the name of the thing to me over and over again. And it's like, great, you got the name, that's important, but what value does this bring to the project? What is this gonna help us do? And they say, but Nate, I need to use this because, well, I wanna put it on my resume. Now, I can't say cloud native without talking about microservices. And for better or worse, an awful lot of developers think if I'm going to the cloud, I have to do microservices. And so folks spend lots of time talking about domain-driven design and looking for bounded contexts and, hey, let's come up with a ubiquitous language, and maybe we should form some of those 2 pizza teams. We kind of skipped a step. And so to paraphrase my favorite fictional chaos mathematician, your developers were so preoccupied with whether they could, they didn't stop to think if they should. Unsurprisingly, that has led to some pain. There's a decent chance that if you're in this microservice architecture, your call tree might look a little something like this. There's a reason these are referred to as Death Star architectures. And presumably this is why Death Stars blow up in, you know, like every other movie. Oops. Now, there are good reasons to adopt microservices, bar none. The reality in software, every single decision we make is a trade-off. It's all trade-offs. Yeah, I teach architecture at the University of Minnesota, and one of the things that I told my grad students last fall, day one of class, was the answer to everything this semester is it depends. That's software. Should we do this? Should we do that? Well, it depends. In one context, this might be a brilliant decision. In this other context, might be the absolute wrong decision. There are no free lunches. As software engineers, we have to understand the cost of that added complexity. It does not come for free. We should very critically ask, does our application even benefit from this? Or have I just added accidental complexity into the equation? Our domains are hard. The problems we're being asked to solve are hard. That is the essential complexity of what we do. We do not need to make this more difficult just because we have tools that will enable us to make it more difficult. Now, I would argue that microservices ultimately are a reaction to these monoliths and these sort of heavyweight SOA-y things we used to use back in the day, as well as the reality of cloud environments. Now, I'm sure many of you at one point or another in your career have worked on a monolith, and you probably didn't necessarily enjoy that particular application. Developer productivity tends to be a little lower in those environments. It can take a really long time to get your head wrapped around these massive, massive code bases. I worked at one company where the expectation was it would take you about a year before you're really productive in the code base. It was that massive. Now, whether or not it should have been that big is a very different question. So long ramp-up times, not a lot of fun. I spent a lot of time thinking about, like, why have we done quarterly releases for such a long time? And I think it was just the reality that for most of software, even if I just made one little change, I had to build and deploy everything. So I might as well wait until I have enough stuff to justify going through the pain of doing a deploy. It's like if you're going to run errands, you usually wait until you have a batch job that's reasonable enough, 3, 4, 5 trips. You're not just going to go one trip out and back, one trip out and back. You're going to try to batch that together. Where scaling during this time period was not a lot of fun. I had to scale up the entire thing. Couldn't just scale up the part that needed a little extra capacity. These systems tended to be really hard to evolve. And some of this is just the reality of the world. At some point in your career, you learned about the second law of thermodynamics. I like to refer to this as the teenager's bedroom problem. I am the proud owner of a teenager. At some point in the last year or so, I was either putting something in my son's room or taking something out of my son's room, and I had a really hard time figuring out where the floor was. And I suggested to my wife, maybe we should ask him to clean up his room. And she stared at me and said, "What hill do you want to die on today?" And I realized, not that one. Now, as much as I wish my son's room was more organized, I also realized that's just thermodynamics at work. The universe wants to be disordered. Although I will tell you, as a total aside, I was putting something in his room recently, and he had clearly picked up, and I was a little taken aback. I'm like, what happened? And I asked my wife, I said, "Did you tell him to clean up his room?" She said, "No." And I said, "What? Why? Is he having guests that we don't know about?" And so I asked him the next morning, I said, "Why is your room picked up?" And he said, "Well, I couldn't sleep last night, so I picked up my room." Like, apparently cleaning equals insomnia, or insomnia is the cure for cleaning. I don't know. Now, software is not immune from this. Every one of you has started on the greenfield project, the thing we all long for. And we've all said, this time, we're going to do it right. And 6 weeks later, 6 months later, you look around and you go, oh man, what happened? We had this golden opportunity, and we wasted it. Well, it's just the nature of the beast. Over time, it takes longer and longer and longer to add new functionality, and so we react to this by saying, you know what, hey, maybe there's another way of doing it. Let's make little itty-bitty microservices or little bitty monoliths called microservices, and that's what we're trying to do today. Now, there is no one definition here. This is very much the definition of I'll know it when I see it. It's in the eye of the beholder. One of my all-time favorite tweets, this is my old boss, Andrew Clay Schaefer, who wants to argue about the definition of made-up words with me. Ooh, we do that a lot in this industry, don't we? I don't agree with your definition. I am partial to anything that reminds us these things are supposed to be small. So anything we can rewrite in 2 weeks or less. Now that does lead to a really interesting question, is how small is small? Sam did a great video a couple years ago about this, and his point is that over time, they'll actually get smaller because you'll have the muscle memory and the tooling and the ability to do this. The first few microservices you do are probably going to be much, much larger than one that you would do in month 6 or year 2. So don't be afraid to deploy things that are actually pretty tiny. I've had a lot of people say, oh, Nate, it's anything that's written by a two-pizza team. I'm not particularly satisfied with that definition for many reasons. First and foremost, like how big is the pizza and how hungry is the team? But more importantly, that gives me no guidance for how many services my two-pizza team can handle. My job before this one, as we were bringing cloud in and starting to kind of migrate towards these more distributed architectures, my director came to me one day and said, Nate, how many services should a team have? And I looked at him and I said, it depends. He didn't like that answer. But it does depend. It depends how volatile those services are, right? If they're super volatile, that two-pizza team can probably only handle a small number of them, 3, 4, 5. They're pretty stable, they're not changing a lot. That exact same group of developers, they might be able to handle a dozen, 20, who knows? Grady tweeted this out. Microservices are just tiny monoliths. Don't tell anyone. Not wrong. I think it's more important to look at these in terms of characteristics. They are suites of small, focused services. Do one thing, do it well. This is a concept that is long been in our space, Linux, Unix. Let's take simple tools, pipe them together to get more complicated output. You know, I gotta tell you, I've thought about this a lot. It's amazing that things work as often as they do in our space. I'm not gonna lie. When you think about how many variables that are at play, how many weird things go on. When I was flying out here, I couldn't check in on the app for some reason, and it just gave me an oops, try again later. Good error message. Thanks for giving me lots of detail here. And I kept trying and it didn't work. And so, okay, they probably just need to scan my passport or something at the airport. And so I went to the ticketing counter and they couldn't get it to work either. And the dude wrote down some numbers and went off in the back room. And 20 minutes later came back and said, yeah, we're not sure what's going on. Apparently I had 2 segments on my return, or I don't know. You know, from my standpoint, I'm just sitting here going, you know, my flight's going to board here in like half an hour. Am I going to get boarding passes so I can, you know, go on this flight that I've already paid for? And I don't know what magic had to happen. I actually had to call at the same time he called the reservation desk. It became a game of who can get there first. I won somehow. And I don't know what they changed. I presume they actually called someone like us and said, can you please go into this row in the database and delete this? That's my guess, ultimately, given how long it took. So it's kind of amazing to me, actually, when it all works. They should be independently deployable. This gets violated more often than you would think. I was talking to a friend of mine about this, and he said, oh, yeah, when we were trying to do this, my previous company, we were kind of halfway down the path to microservices, and we're sort of at that, do we keep going forward, do we go backwards? And he said, we knew we weren't quite there yet when we had this set of microservices, I think it was 7 of them. If you modified any one of the 7, you had to redeploy all 7 of them in the proper order, or else the databases wouldn't initialize properly. But yeah, we knew we didn't quite have it right yet. They should be independently scalable. They give us the ability to evolve at different rates. That's really powerful, by the way. And of course, what gets most of us very excited about microservices is the ability to choose whatever technology we want. Except we often, excuse me, put the cart before the horse here. We say, oh, thank goodness, I finally have an excuse to use insert esoteric language or technology here. Instead of saying, wow, you know what, I think this esoteric language or technology would give us some lift in this particular problem domain. This should be built around business capabilities, and they're ultimately an example of what I refer to as the 0th law of computer science. If you look at almost everything we're trying to do in software, it boils down to this: high cohesion, low coupling. Take a look at the Gang of 4 patterns. Almost all of them are high cohesion, low coupling at different levels of abstraction. Almost everything we're trying to do in design boils down to high cohesion, low coupling. So I would argue microservices are this principle applied to services. Now here's the reality, friends. It's an approach. It's a style. It's a pattern. It's a tool. It is not Mjolnir. It will not solve every problem you've ever had on every project. It will not allow you to, bring lightning down upon your arch nemesis. I'm sorry. And I know that's often how we pitch these things. That's not the reality. The reality is it's just another tool in our toolbox. That's it. The challenge for us is knowing when to pick up which one. Now, I am a software person. I don't know hardly anything about hardware. I'm not particularly handy around the house. If there's a YouTube video and it's like clamp here, remove this, put that, I might be able to do it, but there's a decent chance I'm going to screw it up in one way, shape, or form. So I only have one hammer. One hammer is more than sufficient for me to screw up anything around the house. Now, a few years ago, my wife and I decided that we wanted to finish our basement, and so we weren't going to do that ourselves. I wanted it done in my lifetime, and I wanted it to have sufficient quality, and so we hired the job done. And the folks who came to work on our house, they didn't have one hammer. They had a truck full of hammers. If you've ever gone to like a big box hardware store kind of thing, they have like an aisle full of hammers. Different sizes, different weights, different shapes. Some have kind of a knurling on it. Some have that little hook on the end to pull out the nail you inevitably bent trying to pound it in. What separates me from those folks is they know when to pick up which hammer. A framing hammer is useful for this. A finishing hammer is useful for that. A sledgehammer is useful for this. It's the same for us. We've got all these tools. The challenge is knowing when to use which one. Use them wisely. Now, the reality is, if you're struggling with a monolith, microservices are not going to be magically easier. In fact, in many ways, you've probably made things much, much harder. Love this tweet. I wish I had been smart enough to tweet it before Matt did. Just read the words, large monoliths are unmaintainable. No. Poorly structured systems are unmaintainable. Your deployment topology doesn't matter in that regard. So it's important to understand we've got a couple forces at work here. All right, we've got modularity and we've got distributability, for lack of a better word. Many of you at one point or another in your career have worked on a big ball of mud. By far the most common architectural pattern. I don't think anyone actually sets out to create a big ball of mud. I don't think anyone's in an architectural review defending, for this application, seriously, we're doing a big ball of mud. It makes the most sense. But we often end up here for various reasons. And none of us, I think, enjoy this because we're sitting there going, oh, it's got none of the benefits. It's just very painful to work with. And so we come along and we learn about this thing called microservices and we think, oh my gosh, that's amazing. That's what we should do. Let's take the big ball of mud and migrate it towards microservices, and the skies will part and it'll be sunny and everybody will be happy. Unfortunately, that's not often what we end up with. Instead, we create a distributed big ball of mud. It turns out this is actually the worst thing we can do. It has all of the drawbacks of these distributed architectures, none of the benefits of the modularity, and it's not a great place to be. Very, very painful. What tends to make life simpler is to create a modular monolith. Take our existing monolith, start breaking it up, figuring out where this makes sense. And from there, we can evolve to microservices if that is the right thing to do for this application. By the way, this tends to be easier to figure out what your microservices are going to be from a modular monolith because you have a better sense of where the seams are, what makes sense to sort of split out. It's not quite this, I don't know, I'm throwing stuff at the wall and seeing what sticks. Now, you'll hear some people talk about sort of like right-size services or macro services. And to me, it's sort of this ever-ending kind of back and forth and, what's Goldilocks. And so maybe we'll take the modular monolith and move it towards that. Maybe we'll take some of those microservices and move it towards that. You know what? Do what's right for you and your situation. You have experience. You know your domain. You know what makes sense for you. You might have a service that other people think that's much too large. You might have some services that people think, oh, that's much too small. And you know what? It doesn't matter as long as it's working for you. So don't get too caught up in, well, if it's more than this many lines of code, don't do those rules of thumb kind of thing. Remember Dead Poet Society? I think one of my favorite scenes is where they're starting the beginning of the book. It's like, you can judge a poem by blah, blah, blah. And he's like, rip that out of the book, and it's like, how could you do that? It's the same for us. I can't give you some magic formula that will tell you the exact right size for a microservice for you. You have to figure that out for yourself. I also want to stress that cloud native doesn't mean you have to do microservices. If microservices help you, great. If they hurt you, then don't do it. There absolutely are cloud native monoliths. And in many cases, that's the right thing to do, especially early on when we know the least about the project, by the way. So don't be afraid of the modular monolith. Now, once we start going down this path, we have to recognize that, all services are equal, but some services are more equal than others. We need to think about SLOs. Very critical step when we're trying to make these things production hardened. A lot of times what we talk about is availability. This tends to be pretty darn critical. So what is the availability goal for this specific service? I strongly encourage you to familiarize yourself with the SRE book from Google. You can get this online. It's on the O'Reilly platform. You do not need to read this cover to cover. All right, it is a series of essays, sort of like thematically grouped together. You can read one, put it down for a month, read another one, put it down for a month. So you don't feel like you've got to read this from front to back. One of the interesting things that comes out of this book is reminding people that there is a pretty significant difference between SLAs and SLOs. We have a tendency to abuse this terminology. This all starts with an SLI, a service level indicator of some sort or another. So this is a measure of some aspect of our system. Error rate, throughput, latency, availability. And we usually talk about availability in terms of percentage of time your service is available, or another way of thinking about that is how much downtime is tolerable to your business partners. This is usually referred to in terms of nines. A lot of us have no idea what the nines mean. And a lot of customers are like, give me all the nines. Like, okay, but what does that actually mean? Well, 2 nines means you can be down for a little over 7 hours a month or just over 14 minutes a day. That's pretty reasonable, I would think, for most applications today. 3 nines, we're talking about less than 9 hours per year, less than 2 minutes a day. This is getting a little harder. 4 nines, we're talking about 4.3 minutes a month of downtime, or less than 9 seconds a day. The fastest human being on Earth cannot run 100 meters in that amount of time. So if your application has been down for as long as it takes Usain Bolt to go from start to finish, sorry, you just violated 4 nines. Now you try to go to 5 nines. Well, now we're talking about 6 seconds a week. Less than a second a day. If there's like a power fluctuation, you just violated 5 nines. The scary thing about these nines is you'll occasionally get a customer that locks in on this and says, I want all the nines. Give me 5 nines. I got to have 5 nines. Like, whoa, whoa, whoa. Why? Are we launching people into space? I mean, if you are, by all means, you probably need more than this number of nines. Of course, the real engineers, the people who get degrees and have to get board certified, laugh about these kind of nines. None of us, frankly, would get on an airplane that only had like 5 nines. We'd be like, no, could you please add a few more? We're like quite high in the air. Get that right. Last time I looked, GKE was 99.5. Right, so next time someone in your organization says we need to be 5 nines, well, hang on a sec here. Especially if we're relying on some of these other things, we have to realize that there are some consequences there. Now, from there, we can start to establish service level objectives. So this is our target. What are we shooting for? So we might say, well, we'd like an availability of 3 nines. We'd like our average response time to be under 100 milliseconds. This is hard. This is not straightforward. And it's not always just up to us. Those pesky customers are going to have thoughts. The environment that we live in has an impact here. Think about the way retail has changed in the last 20 years. I remember being younger and it's like, well, the store closes at 9 o'clock. Think about it right now. In this online world we live in, how often have you rage ordered something at 1 in the morning or any time of day? My wife actually did that. We have 2 cats, and when they were a little younger, we used to try to give them the run of the house at night, and they were being very pesky. They kept clawing at our door, and my wife got so frustrated one night, she rage ordered a cage at like 2 in the morning, and now our poor little kitties get crated every night because they can't be trusted. So that has changed expectations. Our customers no longer believe in, well, sure, as long as the application is available Monday through Friday from 6 to 6, that will be lovely. It's like, no, maybe I want to shop for this at midnight. That's the only time I have. Maybe I can't sleep, but I want to do something right now, and it's 3 in the morning. That has an impact on us. We are heavily subject to anything we depend on. You cannot exceed a thing you depend on. I've had people try to tell me, oh, we guarantee 4 nines, and I say, but you depend on something that's 3 nines. You can't exceed that. I'm sorry, that's not how maths work. From there, we might have an SLA, service level agreement. We have a service level agreement when there is a consequence to missing that SLO. If there is no consequence, we don't have an SLA. This implies a contract. This implies a penalty of some sort. So no consequence, not an SLA, it's an SLO. SLAs are not our domain. This is a product decision, this is a legal decision. A lot of people interchange those two, they're not synonyms. And I know that's pedantic, but ubiquitous language. Now here's the thing. When left to their own devices, everyone wants all of the nines. Everyone wants hot until they see how much it costs. This is the definition of if you have to ask, you can't afford it. And one of my team's superpowers is that we will find the best coffee in any city we happen to be deployed to. We take our espresso very seriously. And a few years ago, we had the opportunity to go to South Africa. We were in Johannesburg and Cape Town. And in Joburg, it turns out the best coffee we could find happened to be in this very, very high-end car dealership. Now, I'm not talking like Mercedes, BMW. This was custom stuff. This was Lamborghinis, Ferraris, 1967 restored Corvette kind of things. I mean, these were decked out vehicles. Not a price tag to be seen anywhere. Because if you're shopping there, price is not a constraining factor. It's, ooh, I like the red one. And you know what? Give me the purple one too, because I can. Same thing here. We actually have a client who, this was at Spring One in, I want to say Austin. They showed failover from one cloud provider to another, live, on the keynote stage, while asking the audience to hammer on their website, and showed all the traffic flowing over to another provider. Now that's pretty extreme. A lot of us are not going to do that. They had a business need to do that because they are an online retailer. Well, they also are brick and mortar. But so for them, being down is not an option. Because in that environment, if you are not available, no problem, I'll go to your competitor. Thanks for playing. Maybe I'll come back, maybe I won't. So that's an example where the customers, the business partners understand, yes, no, this is the cost of doing business. When we put these services into production, we're putting an awful lot of trust on them. We trust them to behave. We trust them to perform. We trust them to get the job done. So how do we know if we can trust a service? I would advise you to have a checklist. Now, I understand some of you are looking at saying, you're kidding me, right? We're technologists. Why would we want to rely on a checklist? If you don't think checklists are powerful, I beg you to read this book. Beg you. It's an amazingly good book. So who uses checklists? Pilots and surgeons. Oh, and a lot of you. That's outstanding. I spend more time on airplanes than I care to admit, and air travel is incredibly safe. Why? Because your flight crew, the maintenance crew, is going through a checklist before every flight, after every flight. Many of the items on that checklist are hard-earned. In some cases, people gave their lives for that item to be on the checklist. Same with surgeons. I had my hip replaced a few years ago, and it was a strange experience in many ways, but one of the things that stood out to me is, first and foremost, I've never been asked my birthday so many times in my life. That's like your unique identifier when you're in the hospital, or unique enough. I kind of assumed that they were going to send me like a birthday present or a card or something. No such luck. And the other thing that was really interesting to me is the morning that I went in for my surgery, every single individual I ran into, what are we doing today? Your surgeon literally signs the limb the day before. I thought that was, like one of those urban legend kind of things, like, oh, they don't really do it. No, they do. And the pre-op nurse is looking for the signature, and if they can't find it or it's not legible enough for them, they page the doctor, and the doctor has to come back and sign it again. Now, I understand why they do this. Nothing would be quite so disappointing as coming back into reality and recovery and having your doctor say, well, good news, bad news. Surgery went really well. Turns out we did the wrong limb. Don't worry, we'll do the proper limb, and we'll charge you for both, because that's how the medical industry works, at least in the States. So this turns out to be a really useful thing, because if you were in that and somebody wasn't on the same page, we'd want to find that out before we start cutting. Same for us, frankly. So you want things on your checklist that are quantifiable and measurable. I've done a lot of rewrites in my career, and one of the most frustrating aspects is you go to your customers and say, what would you like this system to do? And they say, oh, well, it should work just like the old system, only better. You're like, great. What do you mean by better? And that's usually when they go silent. So no, I can't just do fast. What do you mean by fast? These things need to be stable, reliable, scalable, fault tolerant, performant. We got to make sure we have monitoring in place, some documentation. And I understand the reaction of a lot of developers when I start talking this way. They look at me and say, whoa, architect guy. I don't have time for all this. I got to move fast and break things. I am capital A agile. Like, cool, I dig you, but how's your velocity when you have an outage? How do your customers react when there's an outage? I've worked on systems where if you're down for an hour, that's 7 digits lost. Every hour, on the hour, boom. Nothing will bring VPs out of the woodwork quite like 7-digit outages. Like, I didn't even know we had this many VPs. And why are you all crowded around me? Now, this does require buy-in from the grassroots as well as support from our management chain as well. So what do we mean by stable and reliable? Well, the reality in these environments is our services are evolving. That is kind of the point. This allows us to move more quickly. This allows us to embrace that always be releasing mindset. But this also means it's a lot like spinning plates. One wobble and the whole thing comes crashing down. So how do I make sure that my systems are stable and reliable? Well, I need a consistent development process. Anytime I commit code, it's got to go through a gauntlet. It's got to make sure that this is ready to go to production. Maybe we do pair programming. Maybe we do good code reviews. We've got this external automated build system. This code's got to go through a pipeline. Maybe we take advantage of feature toggles. One of the things that is very clear is there is a difference between a deploy and a release. For a long time, those were one and the same because we were blowing away the thing that was here before. There are techniques and tools to allow us to deploy code more frequently, release code when our customers are ready. Got to have thorough testing. And that runs the gamut from linting, unit tests, regression tests, integration tests, smoke tests, etc. And it's got to go through this pipeline to get there. There has to be a standardized way of getting code to production. There's all sorts of different techniques we can use here, staging, canary, blue, green. There's a lot of interesting deployment strategies out there. Back in the beginning, the only option we had was nuke and pave. That was it. What we were doing, well, we're taking this chunk of code and we're blowing away the thing that was there before because we have these app server instances that were very expensive for us to set up. And so this was pretty much a YOLO, let's see what happens, cross your fingers, hope for the best. Now, for those of us that lived through this era, we know that that often meant not a lot of sleep. A lot of issues, a lot of breaks, a lot of bugs. A lot of times when we had to tell our customers the application will be down for maintenance for the next 48 hours. Turns out our customers never really liked that. Although, ironically enough, my friend Layla tweeted this out, and this was recent. This was, I think, 21, so this is not even 2 years ago. This application, this website was down for maintenance, and she's like, you're kidding me, right? And so my response to Layla was that certain deployment strategies are not evenly distributed. Now, there was a time where our customers accepted this, that, oh, yeah, no, of course, over the weekend, applications go down. That's not the way the world works today. Your application's down, guess what? Your competitors isn't. And so I will just go to your competitors. There's very little friction in the URL bar these days, isn't there? Now, this evolved to the recreate pattern, which said, okay, well, let's spin down the current version, and we'll spin up the new version. So that has the advantage of being a little simpler, but it does give us fairly long downtime. So that's less than ideal. So that evolved into this concept of a rolling update. So we're going to take some subset of instances, that's usually defined by our window size, and we're going to update those and then move to the next set of instances and rinse, repeat. And hey, that's cool. Hey, good. No downtime. Customers like that. Of course, I got to be really careful with my sticky affinity because not everybody's going to get the same version at the same time, and rollbacks can be a bit of a pain, so I hope you're backwards compatible. And by the way, session management becomes a real challenge here as well. Session has been a pain for a long, long time. That sort of morphed into this idea of blue-green deploys. It's something Martin has written about, something that comes out of the continuous delivery book. The general idea here is that you have two identical deployment environments. The one that is currently serving traffic, you can call that blue if you wish. It's arbitrary. We do all of our testing on the new version on green. If everything checks out, everybody gives it the thumbs up. Awesome. We'll update the routing table, point production traffic at green. Now green is production and blue is idle. Oh no, we found something wrong. No worries. We just switch things back and we're right back to where we were before. Assuming everything checks out, guess what? Blue is now our staging environment and we just ping pong back and forth till the end of time. One of the interesting advantages of this is you are testing disaster recovery every single time you do a deploy. A lot of organizations don't realize they haven't tested this until something really does go wrong and they try to do their disaster recovery and go, oh no, we haven't actually taken a backup of the database in 6 months. I hope that's not a problem. Now, databases are a pain. There's no getting around this. I'm actually fairly certain part of the reason we have so many new interesting data stores, many of which are schemaless, is to help us with these particular problems. Now, this does give us zero downtime. It does simplify the rollback situation, and it does pretty dramatically reduce our risk. It can be a bit more expensive, right? Because I'm essentially duplicating production, although I would argue that's probably worth the expense given all the benefits we gain from this kind of an approach. We still have to think about backwards compatibility. We do have to think about how we drain down transactions. This is usually where someone says, but what about red black? Well, I would argue it's the same thing, different colors. Maybe it's a branding thing. I don't know. I'm not in that part of the world. Some people have told me, oh, no, you don't understand. See, blue, green, technically both versions could be serving traffic, whereas red, black, only one version can serve traffic. Okay, so let's say red, black's a specialization of blue, green. Does that make everybody happy? I don't know. Right? I mean, again, I'll point you at this tweet. Who wants to argue about the definition of made-up words with me? Is that really the most important thing for us to debate in the morning? Probably not. My opinion, same thing, different names. That's it. We can also do canary release, which is, all right, if everything looks good in staging, we feel pretty good about things, we're going to do some real traffic here. This is the canary in the coal mine concept. Let's see if we have an issue before we do a full push. This is going to be some percentage of production traffic, 5, 10, 15, and that can move up over time if we want it to. The important thing to understand here is canaries are serving real-world traffic. If we find an error, got to roll back. Now, how long should we stay in canary? However long it takes. That could be days, that could be hours, that could be minutes. I don't know. I learned a long time ago in software engineering, there's 3 answers that work for every question you're going to get. There's 42. That's the geek check to see who's well read. My favorite pattern as an architect, another layer of indirection. But the answer that I have to give more often than not is one I've already mentioned here today, which is it depends. By the way, some people get really mad at me when I say it depends. I say, oh, Nate, you're cheating. I say, no, I mean, it does depend. It's never meant to be the end of the conversation, by the way. It is the beginning of the conversation. I need to know more. Tell me more about your environment. Tell me more about your world. But this allows us to test real production scenarios without impacting everybody. Huge advantage. No downtime, simpler rollback, but make sure you've got observability correct here so that you know who's seeing what. This can also be time consuming, unsurprisingly. And you do have to think about backwards compatibility. And like other things, session management, sticky affinity can be a real pain here as well. The specialization of this is A/B testing. This is actually very common these days. It used to be only the domain of the big tech companies. It's something we can all do today. It's actually very, very useful. We spend a lot of time in our environments arguing. Well, it'd be nice to have data. So let's put this version out there against this other version and do some experiments. And let's get real world data on which version actually increases sales or conversions or signups or whatever it is we care about. So some percentage of people get the experiment, some don't. We can do some compare and contrast and learn some really interesting things here. Just make sure you've got your observability story straight. And of course, it's possible to break the application. Now, there's nothing that says you can't combine and mix and match. You could do rolling blue-green, canary blue-green, whatever makes sense for you. I think you all know the answer to this question. It depends. It's probably not even the same for every service in your organization or every service on your application. Different services are going to have different needs. Do what's right. There's nothing wrong with that. The thing that might be perfect for your one service in one part of the application might be completely wrong for another application inside the same walls of your organization. Now, the key, no matter what you do, is make sure that you've got a lot of automation at play here. This cannot be manual. This cannot be I bang on the keyboard. Human beings cannot do the same thing twice. That is not how we work. If you are having a hard time convincing people that having automated deploys matter, you may want to familiarize yourself and them with the night capital glitch. This is a really fascinating story. I mean, terrifying at the same extent. There was a trading company that had a zombie software problem. They made a couple of mistakes. First and foremost, they repurposed an old flag. Big no-no. Then they did a rolling deployment, except their operator missed a server. So 7 servers had the new code, 1 didn't. It turns out this is not, in fact, fine. They lost $500 million, 75% of their market value, and they were acquired a week later. The lesson here, releases need to be reliable and repeatable. This does not happen by hoping human beings do the right thing every single time. Because again, we're human beings. We are not repeatable things. Automation is your friend. This will help ensure that you get a good night's sleep. It is yet another example of shift left. It is in our best interest to find issues as early as possible. That is when they are cheapest and easiest to fix. Once the cake comes out of the oven, it's pretty hard to say, oh, I really wanted marble. Sorry, it's too late. It's been baked. Now, it wasn't that long ago that this would have been a differentiator. It's table stakes today. This is what we have to do to compete. Now, to give you an example of what this can look like, GitHub replaced Merge. I'm sure you all remember when GitHub went down for 2 weeks so they could replace Merge and we weren't allowed to do any updates at all. Of course not. They didn't go down at all. They replaced Merge while we were merging code. Now listen, we can have an interesting debate about what sort of like the top 5 or 10 features of any source code management tool would be, but Merge is in that conversation. And they replaced it while we were actively merging code. This is amazing. Now, an awful lot of engineering discipline went into that. This is the literal example of we're fixing the engine on the airplane while we're in the air. You know, and they were kind enough to write about it and tell you what they did to make that happen. Again, a lot of engineering effort and discipline. I bring this up not to say we should all be replacing key things while people are using them, but just to reflect on how often in my career we've agonized over trivial changes. Oh my God, we're changing some CSS. Oh, this is going to take 7 weeks. Really? Probably not. It doesn't have to. Hopefully, at this point, we have almost no production issues. We found them earlier. Now, the other key part of this is the path to production has to be the deployment pipeline. It is very tempting to say, oh, I'll just log in and do a hotfix. Don't do that. That is a bad idea. When you bypass the pipeline, that almost guarantees you're going to have new bugs. Because there's a pretty good chance you didn't put the amount of rigor into that you'd wish. Plus, you're not entirely sure what production is. Been there, done that, got the t-shirt. Don't do that. Roll back. Now, one of the other big challenges here is we better understand all the dependencies we have and plan that they're going to fail. These dependency graphs get a little crazy. There's a reason I keep coming back to this particular picture. Again, Death Star architectures. So what do we do about dependency failure? Well, it depends. Maybe you cache some data. Maybe you've got alternatives, backups. Depends on the criticality. I spent a lot of my career in insurance, and I assure you that people will submit a claim in the middle of a natural disaster, regardless of what time of day it is. You better be able to accept that claim. That does not mean you're going to work on it instantaneously. It might post up somewhere, and then we'll dispatch it later. Services need to have a health check. Now, I live in the Java ecosystem. I do a lot of stuff in the Spring world. Actuator gives you a lot of really powerful things here right out of the box. Don't be afraid to take advantage of that kind of stuff. We need to always be health checking. Because if we're not healthy, well, there's no point in routing traffic, is there? You're going to have some circuit breakers in your organization, no doubt about it. Circuit breaker pattern is something you should be familiar with. This comes from a friend of mine, Michael Nygaard. Works just like the circuit breaker in your house or your flat. If everything's good, the circuit is closed. And my brain always, I have to think through it in my head. When the circuit is closed, everything is good and flowing through. When the circuit is open, we don't actually flow through calls. Make sure that we don't burn out your house. All right, so if we call this service and we're having problems, we open the circuit, make sure we don't continue to call and get more errors. Everything's back to normal, cool, we close the circuit. And it's up to you to define what happens when things aren't working. That allows us to defend the neighborhood. Your services will not last forever. You need to think about decommissioning. That usually means some kind of a deprecation period. I'd love to tell you there's a technical solution to this. Many of the problems we have in software are not solved with technology. This is a cultural issue. How do we communicate to other people, we are changing this? You need to go to this version now. Typically what a lot of folks do is they make that announcement in whatever way makes sense for their organization, and then they have this deprecation period, and they monitor the old call. If we're still seeing calls to it, we better follow up with that team and figure out why they're still calling the old one. The worst thing you can do is just, let them go and hope for the best. Feral services are not a good thing. We need fault tolerance. We cannot prevent catastrophes. We just can't. But we can build fault tolerant services. The SRE mantra, hope for the best, prepare for the worst. Pretty confident the first SRE was actually this person. This is Margaret Hamilton. She worked on the Apollo software back in the day. And depending on which variant of the story you read, she was in the lab. They were doing a pre-launch test or something to that effect. They're testing a lunar landing. And she inadvertently pressed a pre-launch button, and it wiped out the navigation data. And with 1960 era's software, we take it for granted now that your phone will just recalculating when you make a wrong turn. It's just amazing how much of a change that has had, at least in my world, especially when it comes to traveling. That's not how software worked on the Apollo mission. We have more compute power in our pockets than NASA probably had in its entirety back then. And so Margaret did what any good engineer would do. She said, well, wait, we should probably build in some extra software to prevent this. And her superior said, oh, Margaret, that's silly. We don't need to do that. We'll just tell the astronauts not to press that button. You don't understand. They're highly trained. They're astronauts. They're perfect. Yeah, no, they still press the button. Oops, bad things happen. Once again, to talk about my favorite fictional chaos mathematician, failures find a way. So we need to eliminate single points of failure. Now, luckily, by the way, for those astronauts, she at least did get to update the documentation. So when it happened, they were able to recover. I mean, the movie would have had a very different ending, I guess, if that hadn't happened. Now, if you're not sure what the failure points might be, get the right people in the room, draw up the architecture, point at something shiny and say, what happens if this fails? I've done this a fair amount, and one of the responses I get more often than I care to admit is, that can't fail. Oh, it can't. Interesting. Let me count the ways that it can. Humor me. What would happen if it failed? It's hard. We struggle to think through the unhappy path. We're really good at the happy path. The hard part of software is not when everything goes well. It's all of the edge cases that branch out from there. We need to think about the road less traveled. We need to test for those failure scenarios. Does our service respond appropriately? Now, the reality is the only way to really know in many cases is to unleash chaos. Right? Chaos engineering is incredibly powerful. Although I have to admit, I would love to have been a fly on the wall when these concepts first were floated at Netflix. Because think about it. Somebody like us was in a room and said, okay, hear me out. Here's what I'm going to do. At some point, I'm not going to tell you when. I'm going to go down to the server room and just randomly yank out some cables. Everybody good with that? Guarantee that was met rather coolly at first. But those concepts are a huge part of the reason why our expectations now are I can be pretty much anywhere and tap a button on almost any device I have, and high-def TV will stream to me. And I complain. It's like, ugh, it's like 720, not 1080. So we need to intentionally break things, add some latency, shut down an availability zone, kill a machine, see what happens. Now, this shouldn't be ad hoc. You want to monitor it. You want to log it. And, of course, you need to understand that chaos can go rogue. So some things are going to fall through the cracks. Make sure you can detect failures, and when you find them, add them back into your suite. Those could be internal failures, external failures. How's your exception handling? Code's going to have bugs. Sorry, we're human beings. Test. Very common for dependencies to cause an issue, some downstream thing to be a problem. So how does your service recover? Resiliency. Make it fail again and again. Make sure you've got load testing in there. Now, where do we run load testing? Do we do it in staging or perf or something like that? Yeah, it's not the same as prod though, is it? In some cases, people are doing a lot of this in production, which is both terrifying and exhilarating at the same time. Just make sure that there's synthetic transactions. Sam wrote about this. An e-commerce company accidentally ran tests against production and didn't realize they'd made a mistake until a bunch of washing machines showed up at headquarters. Oops. So make sure you're doing that right. HBO at one point sent out this email only for integration testing, and I got to tell you, as a software engineer, I'm like, yeah, I've been there. Yeah, I feel for you. Just make sure everybody knows when you're doing this, especially downstream dependencies. Well, friends, that's all the time I have for you today. I really appreciate your time and attention. Thank you for hanging out with me. Enjoy the rest of your day. Cheers.